Welcome to this comprehensive tutorial on the SHA512 command in Splunk SPL. SHA512 is a powerful cryptographic hash function that generates secure hash values for maximum security requirements. This command is essential for data security, integrity verification, and creating unique identifiers in your Splunk searches. Throughout this tutorial, we will explore how to effectively use SHA512 for various security applications in your data analysis workflows. SHA512 stands for Secure Hash Algorithm 512. It is a cryptographic hash function that produces a 512-bit, or 64-byte, hash value from any input data of any size. The algorithm has three key properties that make it valuable for security applications. First, it is a one-way function, meaning you cannot reverse the hash to get the original input. Second, it is deterministic, so the same input always produces the same hash output. Third, it is collision-resistant, making it extremely difficult for two different inputs to produce the same hash value. The basic syntax for using SHA512 in Splunk SPL is straightforward. You use the eval command followed by the SHA512 function. The syntax is eval hash underscore value equals SHA512 open parenthesis field underscore name close parenthesis. This command takes any field value as input and returns its corresponding SHA512 hash as output. The field name parameter can be any existing field in your data that you want to hash for security purposes. Let's look at a practical example of hashing a username field. In this example, we start with index equals users to specify our data source. Then we use eval hashed underscore user equals SHA512 open parenthesis, username close parenthesis to create a new field containing the hashed version of the username. Finally, we use the table command to display both the original username and the newly created hashed underscore user field. This creates a new field with the SHA512 hash of the username, which can be used for secure user identification without exposing the actual usernames. SHA512 becomes even more powerful when you combine multiple fields before hashing. In this advanced example, we first use eval combined equals username.:timestamp to concatenate the username and timestamp fields with a colon separator. Then we apply SHA512 to this combined string using eval secure underscore hash equals SHA512 open parenthesis combined close parenthesis. Finally, we select the relevant fields for output. This technique is particularly useful for creating unique identifiers by combining multiple fields, ensuring that even if usernames repeat, the timestamp makes each hash unique. One of the most important applications of SHA512 is in password security. In this example, we hash password fields and evaluate password strength. We start with index equals authentication, then create a hashed version using eval pw underscore hash equals SHA512 open parenthesis password close parenthesis. We also add a security evaluation with eval as underscore secure equals if open parenthesis len open parenthesis password close parenthesis greater than 8 quote strong quote weak quote close parenthesis. The main benefit of this approach is that SHA512 provides one-way encryption, which prevents password recovery attacks even if the hash data is compromised. SHA512 is excellent for detecting unauthorized changes to critical files through integrity checking. In this example, we start with index equals files and create a hash of file content using eval file underscore hash equals SHA512 open parenthesis file underscore content close parenthesis. We then use event stats first open parenthesis file underscore hash close parenthesis as original to establish a baseline hash. Finally, we compare current and original hashes with eval as underscore modified equals if open parenthesis file underscore hash not equals original quote modified quote unchanged quote close parenthesis. This technique allows you to detect unauthorized changes to critical files by comparing their current hash values with known good baseline hashes. To conclude, here are the essential best practices for using SHA512 effectively. First, Use SHA512 specifically for sensitive data hashing where maximum security is required. Second, always combine SHA512 with salt values when hashing passwords to prevent rainbow table attacks. Third, monitor the performance impact, as SHA512 is computationally intensive and may affect query performance with large datasets. Fourth, ensure that hash values are stored securely and access is properly controlled. The key takeaway is that SHA512 provides maximum security for cryptographic hashing in Splunk SPL, making it the ideal choice when you need the highest level of hash security for your data protection requirements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.